residential electrical installations, it's crucial to understand the function and necessity of a neutral wire, particularly when dealing with electric ranges. The primary purpose of a neutral wire is to provide a dedicated return path for the electrical current back to the power source, completing the circuit. This is especially important in circuits that serve appliances like electric ranges, which often require both 240 volts for heating elements and 120 volts for controls such as clocks and timers. Without a properly installed neutral wire, the electrical system can become hazardous and non-compliant with electrical codes. The National Electrical Code, or NEC, sets the standard for safe electrical installations in the United States. It outlines specific requirements for grounding and neutral conductors to ensure electrical safety and prevent potential hazards. One of the most critical aspects of electrical safety is the separation of neutral and ground conductors. The neutral conductor is intended to carry the normal return current from electrical devices, while the ground conductor is designed to provide a path for fault current in the event of an insulation failure or short circuit. The ground conductor is connected to earth, providing a low impedance path for current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. Under normal operating conditions, the ground conductor should not carry any current. However, if the ground wire is used as a neutral, it can become energized, creating a dangerous situation. This is because the ground wire is not designed to handle the continuous flow of current that a neutral wire typically carries. If the ground wire is undersized or improperly connected, it can overheat and cause a fire. In addition, using the ground wire as a neutral can create a shock hazard. If a person comes into contact with an appliance or electrical device that is improperly grounded, they could receive an electrical shock. This is because the ground wire is connected to the metal chassis of the appliance, and if the chassis becomes energized, it could create a path for current to flow through the person's body to ground. Some electric ranges are designed with a bonding strip between the ground and neutral terminals of the appliance. This bonding strip is intended to allow the range to be connected to either a 3-wire or 4-wire electrical system. In a 3-wire system, the neutral conductor is connected to the ground conductor at the service panel. This means that the neutral current will flow through the ground wire. In a 4-wire system, the neutral and ground conductors are kept separate, and the neutral current flows only through the neutral conductor. While it may seem convenient to use the bonding strip to connect the range to a 3-wire system, it is important to understand that this type of installation is not allowed by the NEC. The NEC requires that all new electric range installations be wired with a 4-wire system with separate neutral and ground conductors. This is to ensure that the ground wire is not used as a neutral and to provide a higher level of electrical safety. The NEC provides specific guidelines for the installation of electric ranges, including the size of the conductors, the type of wiring methods allowed, and the grounding requirements. These guidelines are intended to ensure that the range is installed safely and correctly and that it will operate properly for many years. When installing an electric range, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific information about the wiring requirements for the range, including the size and type of conductors to use, the proper grounding methods, and any other special considerations. It is also important to consult with a qualified electrician to ensure that the range is installed in accordance with all applicable codes and regulations. An electrician will be able to assess the electrical system in the home and determine the best way to install the range safely and correctly. When retrofitting or replacing an existing electric range, it is important to upgrade the wiring to meet the current NEC requirements. This may involve replacing the existing 3-wire system with a 4-wire system, installing a new circuit breaker, and upgrading the grounding system. Upgrading the wiring can be a significant expense, but it is a worthwhile investment in electrical safety. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. An electrician will have the knowledge and experience to safely and correctly install the range and ensure that it meets all applicable codes and regulations. In summary, it is generally not safe to use the ground wire as a neutral for an electric range. A neutral wire should be installed for all electric range installations in accordance with the NEC and the manufacturer's instructions. This will ensure that the range operates safely and correctly and that it does not pose a fire or shock hazard. The National Electrical Code addresses grounding and bonding requirements extensively throughout various articles. It is important to consult the latest edition of the NEC for specific requirements related to electric ranges and other appliances. Article 250 covers grounding and bonding in general, while Article 400 addresses flexible cords and cables, which may be used for connecting electric ranges. Article 210 covers branch circuits, including the requirements for the number and type of circuits required for electric ranges. In addition to the NEC, local electrical codes may also apply. It is important to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety. They help to protect people from electrical shock and prevent electrical fires. By following the NEC and local electrical codes, you can ensure that your electrical system is safe and reliable. Some specific NEC sections to consider include 250.20, which covers general requirements for grounding and bonding, 250.130, which addresses equipment grounding conductor connections, and 250.140, which covers the connection of the grounded conductor to the grounding electrode system. These sections provide detailed requirements for ensuring that the grounding system is properly installed and maintained. Understanding the difference between grounding and bonding is also crucial. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metal parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are necessary to ensure electrical safety. When working with electrical systems, it is important to use the correct tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. It is also important to wear safety glasses and gloves to protect yourself from electrical shock and other hazards. Before working on any electrical circuit, it is important to turn off the power at the circuit breaker. This will help to prevent electrical shock. It is also important to test the circuit to make sure that the power is off before you start working on it. A voltage tester can be used to check for the presence of voltage in the circuit. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. An electrician will have the knowledge and experience to safely and correctly install or repair electrical systems. Maintaining a safe electrical system is an ongoing process. It is important to periodically inspect the electrical system for any signs of damage or wear. This includes checking for loose wires, damaged insulation, and corroded connections. If you find any problems, it is important to have them repaired immediately. It is also important to keep the electrical panel clean and free of debris. Dust and dirt can accumulate in the panel and cause it to overheat. Overheating can damage the circuit breakers and other components in the panel. To clean the electrical panel, turn off the power at the main breaker. Then, use a vacuum cleaner to remove any dust or dirt from the panel. Be careful not to touch any of the wires or other components in the panel. Once you have cleaned the panel, turn the power back on. In conclusion, ensuring electrical safety in residential installations, particularly with electric ranges, requires a thorough understanding of the NEC, proper grounding and bonding techniques, and the correct installation of neutral conductors. Using the ground wire as a neutral is a dangerous and code-violating practice that can lead to electrical fires and shock hazards. By following the guidelines and consulting with qualified electricians, you can create a safe and reliable electrical system for your home. Additionally, it is always a good idea to consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical safety. They can provide expert advice and guidance to help you ensure that your electrical system is safe and compliant with all applicable codes and regulations. Regularly reviewing and updating your knowledge of electrical codes and best practices is also essential for maintaining a safe electrical environment. Changes and updates to the NEC are released periodically, so staying informed about these changes is crucial for ensuring that your electrical work is up to code. Furthermore, consider participating in continuing education courses or workshops to enhance your understanding of electrical systems and safety practices. These courses can provide valuable insights into new technologies, techniques, and code requirements. Remember, electrical safety is a shared responsibility. By taking the necessary precautions and staying informed about electrical codes and best practices, you can help to protect yourself, your family, and your community from electrical hazards. The NEC serves as a comprehensive guide for electrical installations, but it is not a substitute for professional expertise. Always consult with a qualified electrician or electrical engineer for complex electrical projects or if you have any doubts about the safety or compliance of an electrical installation. They can assess the specific needs of your project, provide tailored solutions, and ensure that all work is performed in accordance with applicable codes and regulations. By prioritizing electrical safety and adhering to the NEC and other relevant standards, you can create a safe and reliable electrical system that will serve you well for many years to come. Finally, keep in mind that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, do not attempt to do it yourself. Hire a qualified electrician to perform the work for you. This will ensure that the work is done safely and correctly and that your electrical system is up to code. The importance of proper labeling of electrical panels and circuits cannot be overstated. Clearly labeled panels make it easier to identify and isolate circuits for maintenance or repairs. This can help to prevent accidental shocks or other hazards. Use a permanent marker or label maker to create clear and legible labels for each circuit breaker or fuse in the panel. Include a brief description of the devices or areas served by each circuit. For example, you might label a circuit breaker as kitchen lights or living room outlets. Accurate labeling can save time and effort when troubleshooting electrical problems and can also help to prevent confusion during emergencies. In addition to labeling, it is also important to keep the electrical panel accessible and free of obstructions. Do not store boxes, furniture, or other items in front of the panel, as this can make it difficult to access in an emergency. Ensure that there is adequate lighting in the area around the panel so that you can see clearly when working on it. Regularly inspecting electrical cords and plugs for damage is another important aspect of electrical safety. Look for frayed wires, cracked insulation, and loose connections. If you find any damage, replace the cord or plug immediately. Do not attempt to repair damaged cords or plugs, as this can be dangerous. Avoid overloading electrical outlets and extension cords. Overloading can cause the wires to overheat and create a fire hazard. Use a power strip with a built-in circuit breaker to protect against overloading. When using extension cords, choose cords that are rated for the amperage of the devices you are plugging into them. Never use extension cords as a permanent wiring solution. If you need to add more outlets, hire a qualified electrician to install them. Educating yourself and your family about electrical safety is essential for preventing accidents. Teach children about the dangers of electricity and the importance of staying away from electrical equipment. Show them how to use electrical appliances safely and how to recognize potential hazards. Discuss what to do in case of an electrical emergency, such as a fire or shock. By promoting electrical safety awareness, you can help to create a safer home environment for everyone. Remember, electrical safety is an ongoing effort that requires vigilance and attention to detail. By following these tips and staying informed about electrical codes and best practices, you can help to protect yourself and your loved ones from electrical hazards. In the context of electric ranges, it's worth noting the specific requirements for receptacle types and configurations. The NEC specifies the types of receptacles that are permitted for use with electric ranges, as well as the proper wiring configurations. These requirements are designed to ensure that the range is properly grounded and that the electrical connections are safe and reliable. When installing a new electric range receptacle, it is important to use the correct type of receptacle and to wire it according to the manufacturer's instructions in the NEC. Using the wrong type of receptacle or wiring it incorrectly can create a fire hazard or shock hazard. Furthermore, it's important to ensure that the receptacle is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or GFCI and energizing the circuit. This helps to protect people from electrical shock and prevent electrical fires. The NEC outlines specific requirements for grounding electric range receptacles, including the size and type of grounding conductors to use. In addition to the receptacle itself, it is also important to consider the wiring method used to supply power to the electric range. The NEC specifies the types of wiring methods that are permitted for use with electric ranges, such as non-metallic sheathed cable or NM cable, and electrical metallic tubing or INT. Each wiring method has its own set of requirements for installation and support. It is important to choose a wiring method that is appropriate for the application and to install it in accordance with the NEC. When running wiring for an electric range, it is important to avoid running the wiring through areas where it could be damaged or exposed to moisture. This includes attics, basements, and crawl spaces. If it is necessary to run wiring through these areas, protect the wiring with conduit or other approved means. Also, make sure that the wiring is properly supported and secured to prevent it from sagging or becoming damaged. It is also important to consider the location of the electric range in relation to other appliances and fixtures. The NEC specifies minimum clearances between electric ranges and combustible materials, such as walls, cabinets, and curtains. These clearances are designed to prevent fires and ensure that the range can be operated safely. When installing an electric range, it is important to follow these clearance requirements carefully. In addition to the NEC, local building codes may also apply to electric range installations. It is important to check with the local building department to determine the specific requirements in your area. Local building codes may have additional requirements for grounding, wiring methods, and clearances. By following the NEC and local building codes, you can ensure that your electric range is installed safely and correctly.